Okay, so today's lesson is about the properties of the trig functions, and then we're going to do some simple graphing or sketching of the trig functions. Okay, so let's have a look at the summary number 1. Y equals sine x has a period of 2 pi and amplitude of 1. Y equals cos x has a period of 2 pi and amplitude of 1. Y equals tan x has a period of pi and no amplitude. Now, if you don't understand, have a look at my previous videos that will explain it with graphs. Okay, summary 2. Y equals k sine ax has amplitude of k, and then period, if you want to find 2 pi divided by a. Okay, and that's the same as y equals k cos ax. That has amplitude of k, period of 2 pi over a. Now, y equals k tan x has no amplitude, as we mentioned before, and the period of pi over a, not 2 pi, pi over a. Now, phase shift of trig functions. So, y equals sine x plus b has a period of phase b, so that's b, which is a shift b units from y equals sine x. Now, I have to think about this. B is positive here, so it's going to be moving to the left. If it was x minus b, it will move to the right. Okay, so it's moving to shifting. Okay, cos x plus b has a phase b, which is a shift b units from y equals cos x. Y equals tan x plus b has phase b, which is shift b units from y equals tan x. Now, let's have a look at center. Okay, center is the middle of the whole period of the wave. Okay, so center of the trig function, that will be plus c. Y equals c is your center. Has a center c, which is a shift up by c units. And if it was a sine y equals sine x minus c, which is a shift down by c units. Okay, so it's sort of like a parabola, if you like. You know, when it's the y-intercept, it'll go up or down. So same thing, similar. So y equals cos x plus c. If it's a positive, it goes up. If it's negative, it goes down. Same with tan x plus c. Now, let's have a look at the total summary of all these now. So if I have something like this, that means, what's this one? K is amplitude. And then C is my center. And A is what I use for period. And the B is what I use for phase, moving left or right. Okay, so that's what it is. And since very much the same as sine, the cosine will be the same, like that. Okay, so have a read on that. And the last one, the tan, will be, so there's no amplitude, of course, the tan, and period will be pi over, not 2, a. And then, of course, whether b is positive here, going to the left, negative going to the right, and c is positive going up, c is negative going down. Okay, of course, k is your, in this case, it's no amplitude. So k is not really saying anything about amplitude. Now, here is simple questions. I'm going to do some simple questions, and then I'll do some more for the next video. Okay, I'm going to assume all these questions will have domain 0 to 2 pi, which is 0 to 360. Okay, now I have to warn you on this one, because my graph will be quite roughly done. Okay, you probably need to use grid paper with a pencil and ruler and rubber and all that sort of thing, but I am not going to do that. So in here, y equals 2 cos x. Only thing I can see different from y equals cos x is there's a 2 in there instead of 1. That means amplitude. So my height will go up to 2 and go down by -2. So roughly, I'm going to sketch here. It is very, very rough. So 0, I'm going to do roughly -2 and 2. Now, my phase of all this will be the same, isn't it? So I'm going to go 2, 3. Oh, it is quite rough, isn't it? Very, very rough. So what I'm going to do here, because I need a bit longer, x, so pi 2 pi 3 pi 2 pi. Okay, whew, that wasn't too bad. Now remember, it's a cos, so we're going to start from right there. Okay, so that's around. Ooh, it's not quite there, but you know what I meant. Okay, next one. Exactly the same, but this time it's going to go up by 5. Yeah, I'm gonna just be careful with how much you're spacing out. Okay, so that's my y, that's my x. 0 pi over 2 pi 3 pi over 2 pi, and I'm going to assume that's 5. That's my -5 there. Okay, and then again, same thing happens. That's very easy. Excellent. Okay, so that's my one. So that's got down to 5 -5, 5. Okay, so that wasn't too bad. Now what happens if still 1 here, 1 here, but there's 2x? What does that mean? It means it's let's have a look. It's gonna happen something to do with the period. Okay, so our amplitude is 1. Okay, amplitude is 1. So I'm just gonna write it here. Capital A for amplitude is 1, and my period, capital P, is 2 pi over A, which is, this is my A, is 2. So it's a pi. My whole pattern is going to complete it in a pi. So if you think about from 0 to 2 pi, and a whole pattern will complete in pi halfway. So I will have 2 sets of whole complete pattern. Okay, so that means the wave's moving fast, isn't it? It's twice fast if you think about it carefully. So here we go. I'm going to go like that. That's my pi here. That's my 2 pi here. And that's pi over 2. That's a 3 pi over 2. So what I'm going to do, my amplitude is 1 and -1. It hasn't changed. Okay, so, and that's a 0. So I need to quickly go like that. Okay, so that's my one pattern, and that's my one period, right? So whole thing completed in pi, and I'm going to go another one right there. Okay, so it's not quite good, isn't it? So that's why you need to use a pencil and practice more. So I've got 2, so it's really, it means 2 pattern. Pattern will happen twice, 2 sets will happen. Okay, here you guessed it, it would be 4 times. So let me see if I can sketch a bit bigger. And it's still 1 because amplitude hasn't changed. But here I'm going to go 1, 2, 3, 4, x. So here we go. So I'm going to go pi over 2, pi, 3 pi over 2, 2 pi. So my pattern has to complete in, let's have a look. My amplitude is 1. My period will be 2 pi over 4, which it will be pi over 2. So whole pattern will complete here, 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 here. So let's have a look. I shouldn't really do it too high, but that's okay. Let me try my best. So that's my pi over 4. So that's one pattern, okay? That's the whole one period, okay? And there are 4 of them, 4, 2 pi, 2 over 2, pi over 2, 4 pi over 2 in a 2 pi. It's a bit hard to say. And then completely like that, and also roughly and roughly. Phew, that's it. Oh, that looks ugly, but you know what I mean. So there'll be a 4 patterns happening in this sine 4x. So I'm just wondering, if it was y equals sine 5x, you will get 5 sets of the whole patterns. Okay, well, that's it then. I'll do some more of the examples next video.